Hello everyone. So welcome to the week 11th of this course for the tutorial session on digital signal processing and its applications. So today we are going to see some of the important questions based on the topics which is taught in the week 11th. So first we'll start now. The first question is which of the following are cascade realization of the system yn is equal to 3 by 4 yn minus 1. Let me check whether this video is recorded or not. Yes, so the video is recorded and will be uploaded on YouTube. And if you have any doubt, you can ask there also in future. So given in this question is y of n is equal to 3 by 4 yn minus 1 minus 1 by 8 yn minus 2 plus xn plus 1 by 3 x of n minus 1. So now we will take the z transform of this. So we will get y of z is equal to 3 by 4 z inverse y of z minus 1 by 8 z to the power of minus 2 y of z plus x of z and plus 1 by 3 z inverse x of z. So now we will separate out the term y of z in the left hand side and x of z on the right hand side. So we will get y of z minus 3 by 4 z inverse y of z plus 1 by 8 z minus 2 y of z is equal to x of z plus 1 by 3 z inverse x of z. So now we will take y of z common on left hand side. So we will get 1 minus 3 by 4 z inverse plus 1 by 8 z to the power of minus 2 is equal to 1 plus 1 by 3 z inverse. So what is h of z? The transfer function h of z is equal to y of z divided by x of z. Output response divided by input response. So we'll get here 1 plus 1 by 3 z inverse divided by 1 minus 3 by 4 z inverse plus 1 by 8 z to the power of minus 2. So we can write this as the denominator part, we can write it as 1 plus 1 by 3 z inverse divided by, so we can write it as, you multiply it, we will get the same 1 minus half z inverse and again minus 1 by 4 z inverse, so that will be 3 by 4 z inverse and plus 1 by 8 z to the power of minus 2. So we can write it as h of z is equal to, so this is our h1 of z and this is our H2 of Z. So we'll see the answers. So option A is the correct answer for this question. Okay, now moving to the question number 2. So consider two single-stage lattice filters cascaded together. The first stage has the lattice constant K1, which is put ahead of the second stage with the lattice constant K2. Find the output from the second stage lattice filter given the input to the first stage is x of n. So for the first stage, that is E1 of Z, first we'll find for the first stage, that is equal to E naught of Z plus K1. The first stage has the lattice constant K1. So K1 Z inverse E naught hat of Z. Or we can directly write E naught of Z. So in time domain, given that input is x of n, so it will become f1 of n is equal to x of n plus k1 x of n minus 1 and f1 n. So this will become k1 x of n plus x of n minus 1. Now for stage 2, E2 of Z can be written as E1 of Z plus K2 Z inverse E1 hat of Z. So in time domain, how can we write this? F2 of n is equal to F1 of n plus K2 F1 of n minus 1 hat. So F2 of n, from this equation 1, we will use equation 1. F1 of n is xn, sorry, here it is K1. K1 is here. Plus K1 x of n minus 1 plus K2 K1 x minus n minus 1 and plus x of n minus 2. So F2n, the final answer will be x of n plus K1 1 plus K2 x of n minus 1 plus K2 x of n minus 2. So the final answer will be x of n K1 1 plus k2 xn minus 1 and k2 xn minus 2. Option C is the correct answer for this question. So now we'll move on to the question number 3. So it is given the parallel realization of the cascaded architecture of the discrete system shown in this figure, and Hz is written in partial fraction form as follows. So which of the following options are true about A, B, C, D? And this is are the floor and ceiling functions respectively. So what is given here? H of z. The transfer function is given, that is A plus bz inverse divided by 1 minus 2z inverse plus 0.25 z to the power of minus 2 plus c plus d z inverse divided by 1 minus 3 z inverse plus 0.2 z to the power of minus 2. Okay, so this is the transfer function given in terms of a plus b. Now from this figure, what is the transfer function? So when we get the transfer function from this figure, h of z will become 1 plus 0.25 z inverse divided by 1 minus 2 z inverse plus 0.25 z to the power minus 2. This is from the first part, and from the second part it is 1 minus 3 z inverse and then plus 0.2 z to the power of minus 2. So we can write it as 1 divided by 1 minus 2 z inverse plus 0.25 z to the power minus 2 multiplied with 1 plus 0.25 z inverse divided by 1 minus 3 z inverse plus 0.2 z to the power of minus 2. Now coming from this, h of z is equal to, now we will substitute all the value. Oh, here it is given in the plus form, and in this it is given as a multiplication form. Okay, so when we write h of z in multiplication form, we will get a plus dz inverse multiplied with 1 minus 3 z inverse plus 0.2 z to the power of minus 2 plus c plus dz inverse multiplied with 1 minus 2 z inverse plus 0.25 z to the power of minus 2 divided by, we can write like this. And now we will separate it out with the term with the coefficients z to the power of 0 and z to the power of minus 1. So the numerator can be written as a, so we can directly write it here and imply that 1 plus 0.25 z inverse, like this. this numerator part is equal to this complete numerator part. Okay. So this is equal to A plus B Z inverse 1 minus 3 Z inverse plus 0.2 Z to the power of minus 2 plus C plus D Z inverse 1 minus 2 Z inverse plus 0.25 Z to the power of minus 2. Okay. So when you write like this, now we'll separate out all the coefficient, uh, like A plus C is the coefficient for Z to the power of 0 minus 3A plus B minus 2C plus D is the coefficient of Z inverse plus 0.2A minus 3B plus 0.25C minus 2D is the coefficient of Z to the power of minus 2 plus 0.2B plus 0.25D Z to the power of minus 3. So now A plus C will become 1. Okay. So A will be like when you find it, you will get minus 2.2. B will be 0.26. A plus C is 1. So C is equal to 3.2. And D is equal to minus 0.21. Okay. So A is less than 0. Yes, option A is correct. Floor of B is equal to floor of D. No, it is wrong. Now floor of C is equal to 4. Yes, it is correct. And floor of, sorry, D is greater than 0. No, this is also wrong. So option A and C is the correct answer for this question. So now we'll move on to the question number 4. For the system given below, which of the following options describes it as a parallel network of first order direct form structures? First order implies that number of poles of subsystem is almost 1. Okay. For the given system, it is asking which of the following options describe it as a parallel network of first order direct form structures. So first we will write h of z is given, that is equal to 32 plus 18 z inverse minus 2 z to the power of minus 2 divided by 8 plus 2 z inverse minus z to the power of minus 2. So what we will do, we will divide it by 8 in numerator and denominator. So we will get, like, divide it both by 8. Then what we will get, 4 plus 18 by 8, that will be 9 by 4 z inverse minus 1 by 4 z to the power of minus 2 divided by 1 plus 1 by 4 z inverse minus 1 by 8 z to the power of minus 2. Okay. So now do the factorization of the denominator. So we will get it as 1 plus half z inverse multiplied with 1 minus 1 by 4 Z inverse. So now to implement Lz as a parallel network, to make Hz as parallel network, we can write Hz as A plus B divided by 1 plus half Z inverse plus C divided by 1 minus 1 by 4 Z inverse. Okay. So now to find the constant A, we have to divide minus 1 by 8 Z. Just give me time, I got a call. So we have to divide the denominator, like numerator divided by denominator. So divided by minus 1 by 4 Z to the power of minus 2 plus 9 by 4 Z inverse plus 4. So when you multiply it by 2, what we will get? We'll get minus 1 by 4 Z to the power of minus 2 plus 1 by 2 Z inverse plus 2. Now subtraction will give us 2 plus, and this will be 9 by 4 by 2 by 4. It will be 7 by 4 Z inverse. So h of z can be written as 2 plus 7 by 4 Z inverse divided by 1 plus half Z inverse multiplied with 1 minus 1 by 4 Z inverse. So now we have to find B and C. So B and C can we find out using the partial fraction decomposition of the second term hz in this equation. So we will get, when we do partial fraction, we will get 2 plus 1 by 1 plus half Z inverse plus 3 by 1 minus 1 by 4 Z inverse. So this is our A, this is B, and this is C. So we can now draw the structure, like the parallel network. So the parallel network will be like this. So input is given. Now the first is the 2, and that is coming as the output. Second is minus half, and that is Z inverse. And the third one is 3 into, so here it will be 3, and again it will be here Z inverse, and this will be 1 by 4. So this is complete H of Z, and this is our input, and right hand side is the output. So finally H of Z is equal to 2 plus 1 by 1 plus half Z inverse plus 3 by 1 minus 1 by 4 Z inverse. So the correct option is, sorry, here it will be a negative sign when you do partial fraction decomposition. And for that we have to multiply it by minus 1. So the correct answer is option number A for this question. Okay. So now we will move on to the next question, and this video is also recorded, so it will be uploaded on the YouTube as well. So in this question, it is let's draw it. So this is our y of z. So find the ratio of y by z divided by x of z. So the transfer function it is asking. So here we can write e of n plus 1 z is equal to en of z plus kn plus 1 z inverse en of z kn plus 1 en of z plus z inverse en of z. So using 1 and 2, both the equation we can write e1 of z is equal to e naught of z plus z inverse e naught of z. So that is equal to 1 plus z inverse of y of z, and e2 of z is equal to E1 of Z plus K2 Z inverse E1 of Z. So this is equal to 1 plus 2 Z inverse 1 plus Z inverse Y of Z. Okay. And this is equal to X of Z. So what is our Y of Z divided by X of Z? That is equal to 1 by 1 plus 2 Z inverse 1 plus Z inverse. So the correct option is option number B. Here is the find the ratio of yz by xz for the flow diagram. Here you can see like this z inverse is coming. So the first thing is this option C or option D have z inverse directly going towards the output. And it is a parallel architecture with z inverse in parallel with the system. And now this system is same as the system in the question number 5, the previous question. So our h of z, that is equal to y by z divided by x by z, is equal to z inverse plus 1 by 1 plus 2 z inverse multiplied with 1 plus z inverse. So option C is the correct answer for this question. How many unit delay elements will be required if we realize the given h of z using the parallel architecture with a lattice structure discussed in the lectures? The transfer function is given. Here you can see the degree of denominator. Hence, number of steps to be used in the lattice is equal to number of delay elements to be used in the lattice, that is equal to 2. And in this, an additional delay unit is also required for the 2z inverse component of the parallel architecture. So the option will be 3. Answer will be 3. We'll take one question apart from this PDF, apart from this presentation. Just we'll take a simple question so that things will be more clear. So the question is, determine the parallel realization of the IIR digital filter where the transfer function is given as h of z is equal to 3 2z squared plus 5z plus 4 divided by 2z plus 1 z plus 2. So we have to find the parallel realization. So the partial fraction expansion of hz by z is first determined, and just we did for inverse z transforms. So here we will take f of z is equal to h of z divided by z. So this will become 3 by 2 2z square plus 5z plus 4 and divided by z plus half z by z plus 2 simply. So now we can write this as f of z equal to a1 by z, a2 by z plus half plus a3 by z plus 2. So we are just doing the partial fraction expansion of h of z by z, that is f of z. So now we know that a1 can be written as z into f of z, given that z is equal to 0. So 3 by 2 2z square plus 5z plus 4 divided by z plus half and z plus 2. Okay, and here z is multiplied, so this z will get cancelled. So now when you substitute z is equal to 0, we will get 3 by 2 into 4 divided by half into 2. So it will be 6 by 1. So it is equal to 6. Now a2 will be z plus half into f of z, such that z is equal to here minus half. So this is equal to 3 by 2 2z squared plus 5z plus 4 divided by z plus 2. So now substitute z is equal to minus half. So we will get 3 by 2 2 into 1 by 4 plus 5 into minus half plus 4 divided by, so we will get 3 by 2 half minus 5 by 2 plus 4 divided by minus half into 3 by 2. So this will become 2.5 2. So 3 divided by minus 3 into 4. So it is equal to minus 4. So A2 is equal to minus 4. So now the next is A3. So for A3 we can find z plus 2 f of z such that z is equal to minus 2. So this is our A3. So it is 3 by 2 2z squared divided by z into z plus half. Now, so this will become And here we have to substitute z is equal to minus 2. We will get 3 by 2, 2 into 4 minus 10 plus 4 divided by minus 2 minus 3 by 2. 12 minus 10 is 2 divided by 3. So this will become 1. So finally we got Hz by Z A1, that is 6 by Z, minus 4 by Z plus half plus 1 by Z plus 2. So this we got. Now we will take Z that side. So h of Z is equal to 6 minus 4 by 1. Sorry, we can take 4Z, Z plus half plus Z by Z plus 2. So now we can write 6 minus 4 by 1 plus half Z inverse plus 1 by 1 plus 2 Z inverse. So now we can do this as a parallel realization. So this is our h of Z. So the first part is the input we will take. Now from this input, the constant is going 6. So we will write here 6. And this is our output, y of n. The second part, the constant is minus 4. The third one, the constant is 1, that is A1, A2, A3. And here it will be minus 2. Okay. So this is the parallel realization of the given transfer function. First, what we have done, we have find f of z, that is h of z by z, and then we have found the coefficient a1, a2, and a3, and then we took the z to the right hand side and we found the h of z. So after that, we got the three different uh, like h1 of z, h2 of z, and h3 of z parallelly, and we have drawn the parallel realization of this given transform function. Okay, so now we'll move on to the next question. Realize the system given below using the lattice structure as discussed in the lectures. So h of z is given as So A2 of Z is given as 1 plus half Z inverse multiplied with 1 plus 1 by 3 Z inverse. So this will become 1 plus 5 by 6 Z inverse plus 1 by 6 Z to the power of minus 2. So this we can write as 1 plus K1, 1 plus K2 Z inverse plus K2 Z to the power of minus 2. So from here we will get K2 is equal to 1 by 6 and how much will be the K1? So 1 by 6 plus 1, that is equal to 7 by 6 equal to 5 by 6. So 5 by 7. Now we have to find the coefficient C0, C1, C2. So C0 plus C1 5 by 7 plus Z inverse is equal to 1 plus 1 by 4 Z inverse. So from this we will get C1 is equal to 1 by 4, C0 is equal to 23 by 28. So now we will draw the signal flow diagram. So the signal flow diagram will be like this. So this is E2 of Z, and here it will be minus 1 by 6. This will be 1 by 6. Sorry, this will be minus 1 by 6. E1 of Z is the signal flow diagram for the given question. So now moving to the next question. For the nth stage system, A and Z is defined as per the lecture as in the lecture for the nth stage system, A and Z is defined as En of Z divided by E naught of Z. So option B is the correct answer for this question. So there is a degeneracy in the system if at any stage the lattice parameter k of n takes the value. So an of z is equal to a n plus 1 z minus z to the power of minus n plus 1 k n plus 1 a n plus 1 Z inverse divided by 1 minus k squared n plus 1. So if there is a degeneracy in the system, if at any stage there is d if at any stage so it implies that what will be k squared n plus 1, this will be 1. So k of n plus 1 is equal to plus minus 1. Okay. Now take one more question. Realize the following. Causal linear phase FIR system. And the transfer function is given as 2 by 3 plus z inverse plus 2 by 3 z to the power of minus 2. So here equal valued coefficients are like we can combine, and now the system function can be written as h of z is equal to z inverse plus 2 by 3 1 plus z to the power of minus 2. So now how can we express this? Let's suppose this is our input x of n. So here it will be 2 by 3. Now there should be one more delay unit. This is our y of n. Okay. Because it is z inverse plus 2 by 3 z to the power of minus 2 plus 2 by 3. Now this can be also realized as one more structure. Like first you take input x of n. This is z inverse. Again you take. So now what is the 2 by 3, and this will be our y of n. In the both the way, it can be two equivalent structures can be shown. So today we'll end the lecture here only. If anybody have any doubts, they can ask. And also, this video will be recorded and it will be uploaded on the YouTube. You can ask there also if you feel any difficulties. So now, next we will meet in the next Monday, 7 to 9 p.m. That is on the 14th of April. So today we will in the lecture. So thank you everyone. And many students did not join at this time. So the video will be recorded and it will be uploaded on YouTube. If you have any difficulty, then you can ask in the YouTube comment sections also. There we will reply.